This is a 16 series 48 volts 400 amps LiFePO₄ BMS. Some may ask if a BMS like this could handle the lithium batteries used in forklifts that lift several tons of cargo. After all, the working current is quite substantial. As a safety management system for lithium batteries, choosing a qualified and reliable BMS is crucial. Can it really withstand the load? One test is very important: the temperature rise test. What does that mean? We conduct charge and discharge tests based on the continuous overcurrent value marked on the board. Then, we determine its performance by the temperature rise data. If the board is falsely labeled or genuinely can't handle it, then the temperature rises very quickly and goes very high. This might indicate that the board has a problem. This is a charge-discharge copper case protection board. What does that mean? It means both charging and discharging can achieve a 400 amps working current as marked. Next, we will conduct an actual test at the 400 amp standard. Let's see if it can hold up. This is a dedicated charging and discharging test system for lithium battery packs. You can think of it as both a charging power supply, which provides current, and an application load, which receives current. This allows for a charge-discharge cycle. Moreover, it can support currents up to 1600 amps. Next, we will use this equipment to connect our current battery pack and BMS. We'll perform a real-time 400 amps discharge current for the BMS's temperature rise test. Let's start. If we set the discharge current to 400 amps, ideally, the battery pack capacity should be greater than 400 amps hours. This allows for a discharge test lasting up to 1 hour. However, it's really hard to find such a large battery pack capacity in my warehouse. I found a 300 amps hours one. It can discharge for about 40 minutes. So we will conduct a 40 minutes temperature difference test. The wiring here for the BMS, including the output lines, is all set up. Now let's plug in the NTCs. This board comes standard with 2 NTCs. Since we are measuring the board's temperature rise data, we will place the 2 NTCs in 2 different locations. One is placed here. We also detect temperature changes at different positions on the board's bottom. Now let's plug in the Bluetooth module. Soon I'll be able to see the NTC by the common probe via the app. Okay, before we start, let's record the initial temperature of the board. Then we'll record the temperature change every 5 minutes. We have 2 ways to measure the temperature. First, we can use the temperature gun in our hand. Second, we can be viewed through the Bluetooth app we'll use later, showing the temperature changes from the bound temperature probe. The thermometer currently shows 27.6 degrees. Now let's use our smart BMS software to check the temperature changes detected by the probes. You can see that both temperature probes display 27 degrees for T1 and T2. Then we set the output current on the computer. Alright, let's use the clamp meter to measure the current. It's 402 amps now, and it's discharging. Let's see the data changes every 5 minutes. Alright, after about 40 minutes, the temperature rise has stabilized from the standard room temperature of 27 degrees to 63 degrees now. A temperature rise of over 30 degrees is still acceptable. Plus, our current environment is an open space. For example, if our ambient temperature were a bit lower compared to outdoors and with the board's automatic fan cooling, you might be in a confined workspace during daily use. So the board's temperature rise might be slightly higher. However, as long as the overall temperature rise below 50 degrees is acceptable, the board's protection temperature is generally 75 degrees plus or minus 5 degrees. Another thing I want to mention is that for such a large board, it's best to use 2 standard output cables connected to both ends. Today, we only connected one cable, connecting one cable to a 400 amp board. Honestly, for the cables, over current capacity, it gets a bit hot. In daily use, you should still connect 2 cables. That would be more reasonable, okay? Today's test ends here. The board is qualified? No problem. Also, when choosing a suitable BMS, the current marked on the board must be the continuously passable current. For example, when you're considering choosing a BMS for a car starter, it will indicate how much instantaneous starting current it can support. What else do you want to see next time? Let us know.